Okay, hi everyone. Um, just going to quickly go over how to analyze the planning fallacy data, which will be really straightforward. It's actually the same as it was for incubation and the testing experiment. So open up the Excel file that's on Canvas under this module. Here's the data. These are just in minutes. So how many minutes you estimated it would take you to read the article, and then the actual time it took you to read the article. So let's just get our means first. We'll get those into SR stats anyways, but it's a good skill to have. So just equals average, and then the range you want. So A2 to 8.5. Okay. Then just copy that. And paste it over here. So there's our scores. So estimated versus actual. Obviously, they're probably not different. They're pretty close. If anything, it's kind of in the opposite direction than what we predicted. So the estimated time is actually, we'll see if it's statistically significant, but it appears to be bigger than the actual time, which is the opposite of the planning fallacy. So that would suggest our experiment was probably had problems. I've actually ran this same experiment a whole bunch of times, and it's never worked. I thought it might have a chance online for some reason, but the reason I actually do that is because it's a good learning opportunity. And like I said, a lot of your projects are not going to work. So kind of writing your discussion based on a null result will be good practice for that. Okay. So open up VASAR stats, VASSAR stats.net. It's going to be just two conditions. So it's going to be t-tests, two sample t-tests, correlated, because remember, correlated means within subjects for repeated measures. Independent is for between subjects. Okay, so just copy one column at a time, but don't copy the means here. How does it do that? Okay. Paste it here. Then do the same for actual time. Again, don't grab the mean. Put that in the other one. Hit calculate. So what are we showing here? Well, there's our t-test, degrees of freedom. Use the two-tailed p-value. What this is showing is that it's not significant, obviously. So remember what we talked about in terms of sample size and statistical power and stuff like that. Our sample size was not that large. It was 25. But remember, we also said that you can kind of roughly judge. It's not perfect, but you can kind of get a sense of whether it might have been an issue of sample size based on you actually see the direction and the p-value. So what you hopefully notice here is that, well, for one, it's not even in the direction we predicted. So the other thing is the p-value is not really close. So what does that tell us? Well, it tells us that there was probably no effect there. It probably, if on the other hand your p-value was pretty close, we'd probably think that there's just an issue of a small sample size, and with more people it would be significant. But since it's not even close with 25 people, and it's also not even in the direction we predicted, there's probably no effect there. So keep that in mind. That's it for the analysis. everything you need is here. So let me know if you have any questions.